Hello all, welcome to my class. My name is Pooja Divedi and today we are going to talk about all the important space related events that could reflect in your UPSC prelims paper. I know UPSC has been delayed, but you will get less time for mains examination. So do not get too much excited. Concentrate on covering the prelims related aspects now. Now, if you're new to this channel, make sure that you're a subscriber to my Telegram channel because whatever PDFs I use here is available there. Other than this, if you're going to talk to me about anything related to UPSC, you will find me on my Instagram. And if you have any suggestions, that's also welcome. And here is my threads. Let's start with one of the biggest achievements of ISRO, the soft landing of the Chandrayaan 3 mission on the south pole of the moon. With this, India has become the first country ever to do so. To do what? To soft land on the lunar surface in the south pole. Remember that. On 23rd of August, this is a very historic date for India, 2023, we soft landed on the pole, south pole of the moon, and we have joined a band of countries who were able to soft land. What does it mean by soft landing on the moon? Soft landing actually means that we were able to keep our lander intact and activated while we landed gradually. We did not crash land it. We did not throw away our lander and rover all of a sudden. And by activated and of course intact, I mean after that also the lander was able to perform a hop test. I will talk about that as well. So this point where Chandrayaan 3 has made a contact has been named by ISRO as the Shiv Shakti point. And Shiv Shakti point, there was a lot of controversy about how can we name it. I will talk about naming procedures as well. So make sure you are there till the end of the class. So what were the mission under Chandrayaan 3? Chandrayaan 3 is the third mission in the series and this wanted to show soft landing on the lunar surface. If Chandrayaan 2 would have landed, this would have been a sample return mission. But now we are going to do the sample return mission with the help of Chandrayaan 4, which is different from LoopX. Do not get confused between LoopX and Chandrayaan 4. I will talk about LoopX as well. We also showed the rover moving or roving on the moon, which was named as Pragyan. The lander was named as Vikram. In situ, scientific experiments were also conducted because if we ever have to colonize the moon, we should know what kind of experiments we can do. The mission life was very less, one lunar day, which is equivalent to 14 Earth days. We were too much dependent on solar power. That is why we could only use the power from the solar arena that we were getting. Who launched it? The Launch Vehicle Mark III or GSLV Mark III rocket launched it. And also we sent a propulsion module. You must be wondering, what about the orbiter? The orbiter was already present. If you remember, we sent an orbiter with the help of Chandrayaan 2. So we used the orbiter of Chandrayaan 2. We provided solid fuel, liquid fuel and cryogenic fuel engines. The lander payloads consisted of many things. The payloads are the things that we send in order to achieve certain requirements whenever we are going to send any mission. So lander consisted of CHASTE. What does CHASTE stand for? It stands for Chandra's Surface Thermophysical Environment. Sometimes you have to remember the names as well because UPSC can ask you what was the purpose of Chandra or CHASTE. Okay, so to measure the thermal properties, we had to see if lunar regolith, the lunar soil, basically had any heat properties in the polar regions or not. Rambha, which was a Langmuir probe, it wanted to know about the plasma density, near surface plasma density, and how the electrons change. Instrument for lunar seismic activity wanted to know if there were any earthquake or seismic activities on the lunar surface. Laser retrieve reflector array wanted to understand the dynamics of the moon. These were with lander. Then we had rover payloads. The rover Pragyan, which was moving. We had laser induced breakdown spectroscope, which wanted to study the chemical and mineralogical composition of the lunar surface. What were the minerals that were used when the moon developed? Other than this, alpha particle X-ray spectrometer APXX that wanted to study elemental composition of lunar soil and rocks. Moving on, the propulsion module had SHAPE. SHAPE wanted to study the Earth from lunar orbit. Spectropolarimeter of habitable planet Earth. Remember, sometimes it can be questioned which module carried what. So propulsion carried spectropolarimeter, rover carried LIBS and APSXS, and lander consisted of CHASTE and Rambha. and also ILSA and LRA? Yes, these can be asked. Let's move ahead. Why did we want to understand the lunar surface, specifically in the polar regions? Because the environment in the polar regions is very rugged and it is unexplored till date. So we wanted to explore it. Indications have been there of the presence of ice molecules. That means if water is present, how we can explore it more. Many parts actually lie in complete dark regions, and temperatures there can go below minus 230 degrees Celsius, which can create difficulty in operation of instruments. So we wanted to ensure if ever we are going to colonize the moon, how we are going to let our instruments work. Large craters are all over the place. So we wanted to know what are the kind of fossils that are hidden in these craters, such as Shackleton, Aitken. Certain parts of the moon are actually permanently shadowed. They are beyond our reach of light. Because of the oblique angle of sunlight, the axial tilt of the moon is 1.5 degree. That doesn't let the sunlight to reach certain parts of the poles. The moon's surface is covered with various features, which includes craters, mountains, valleys. So it was important to understand how is it relevant and how can we make sure that if we ever colonize and perform our station work over there, how can we do so? They create natural shadow zones where sunlight cannot penetrate. That means hidden treasures. If we are able to seek out these treasures, we will be able to solve the mysteries of the world. Other thing we have to know about over here, many students may get confused that Chandrayaan 4 is equal to LUPEX, which is completely wrong. ISRO and Japanese Space Agency, which is JAXA, Japan Aerospace Exploration Agency, is developing LUPEX, which will consist of a lander and a rover. And it will study water ice at the moon's south pole. And here, Chandrayaan 2's and 3's, whatever studies have been done, whatever researches have been done, it is going to help LUPEX. Moving on. Let's compare Luna 25, which was a failed mission of Russia, with Chandrayaan 3. Now, there are certain things that can be asked in our examination with respect to Luna 25, so please pay attention. Luna 25 is actually the first lunar mission of Russia after the Soviet Union disintegration. Before this, also, Lunas were sent. That is why numbering has been done Luna 25. But since a long period of time, Russia's moon missions were dormant and it was reawakened with the help of Luna 25, but it failed unfortunately. Ours was a success. India became the first country to land softly at the South Pole. The time taken to reach moon was 12 days for Luna 25. It used a lot of fuel and it was a direct trajectory. That is why less days were used. For us, it was 41 days. We followed a circuitous route like this and we did not went directly. So keep that in mind. Circuitous route was done owing to its relatively heavier payloads. We were sending more payloads and less fuel storage was there of launch vehicle Mark 3 and GSLV Mark 3 rocket. That is why with that less amount of fuel, we had to move it in a circuitous route. However, for Luna 25, there was more fuel storage. That is why it was able to make a direct trajectory. Also, it took less days for that. Luna 25 didn't carry a rover. Ours consisted of a rover named Pragyan. Our landing was solar powered, lifetime of one lunar day only, that is equivalent to 14 Earth days. For Luna 25, it would have been a year. Just imagine if that could stay for over a year or almost a year, how many more mysteries could have been solved. Our worked only for one lunar day, that is 14 Earth days. And because it doesn't have a heating mechanism to keep electronics safe from the extreme cold temperature during lunar night, it was very probable that that was enough for it. Luna 2 was the first spacecraft to reach lunar surface, which made the Soviet Union the first country to reach the surface of the moon. With Luna 2, it all started. Luna 3 returned first images of the far side of the moon that is permanently darkened. Luna 9 was the first one to make a lunar soft landing. Remember, okay, here it is written Luna 2 was the first spacecraft to reach lunar surface. That means it was a hard or crash landing. That means the lander was all of a sudden smashed into the ground. But Luna 9 was the first one to make a soft landing. It was gradual in nature, in a very graded manner, and the rover and the whatever they sent, the payloads were very intact and they were working. Luna 10 was the first spacecraft to orbit the moon. So these are the kind of things that could be asked. Be very clear. All here you have to play a game of clarity only. That is only what you have to do. Moving on, we also performed a hibernation and hop test. That means before finally Chandrayaan 3 went into the sleep, forever sleep mode, it moved from or hopped from the place where it landed to another place. That means we wanted to show our technical capabilities. If we have done it again, we can do it again. Okay, so important discoveries, let's talk about which were made by Chandrayaan 3 included. It confirmed the presence of sulfur near the moon's south pole. Then we also provided a range of understanding on temperatures. Temperatures on the lunar surface drastically drops to nearly minus 10 degrees Celsius just below the surface. This suggests that lunar surface has insulated the subsurface from heat. Very nicely explained, very nicely told. Shiv Shakti point is the point where Chandrayaan 3 landed. Tiranga is the point where Chandrayaan 2 crashed. And Chandrayaan 1 crash site has been named as Jawahar Sthal. And because we soft landed on this date, it is going to be celebrated as National Space Day, something that you have to remember. Now, who names the landing sites on the moon? See, the moon doesn't come under the jurisdiction of any country. According to the Outer Space Treaty of 1967 says that the moon and other celestial bodies are not subject to any national appropriation. We cannot say that this part of the moon is where we landed through Chandrayaan 3, so it belongs to us. It cannot be claimed in this manner. The International Astronomical Union is actually responsible for naming celestial objects. However, ISRO and many other space agencies name the sites informally. Remember, it is named informally, but eventually it has to be submitted to International Astronomical Union in order to make sure that the names are formal in nature. All right. So initially, the lunar sites were named informally due to limited information, but later on formal names were given. But however, it has been submitted to IAU for approval. Now let's talk about the Aditya L1 mission. This is, remember, there are certain points that you have to keep in mind. This is India's first solar mission and also India's first space based solar observatory. Keep your mind on certain keywords. It is in space, that is why space based. It is going to study the sun, that means solar, and then we have observatory. So we have many things, many keywords to remember here. India's first space-based solar observatory it is. All right, and it is going to understand the various layers of the sun's atmosphere for the next 5 years. One thing you have to keep in mind when I'm talking about keywords are the words you have to pay special attention to. Because if the question asks, which is India's first space-based observatory, that is going to be AstroSat. But if the question asks which is the first ever space-based solar observatory, that is going to be, of course, Aditya L1. What is L1? L1 is the point, Lagrange point, where Aditya L1 is situated. It means it is situated at the Lagrange point 1. We have 5 Lagrangian points. I'm going to talk about that as well. Remember that this Lagrange point is 1.5 million kilometers away from the Earth. This is just 1% of the distance between the Earth and the Sun. Now, ISRO will become the third space agency after NASA and ESA to place an observatory at the Lagrange point 1 between the Earth and the Sun. The objective is to study the solar atmosphere and examine how the emissions happen, because these solar coronal mass ejections and solar flares can damage our satellite. They are damaging to our satellite, so it is important to understand that how we can stop, if not stop, how we can work around them. Okay, moving on. See, this is Lagrange 1, which is 1.5 million kilometers away. Now, we are great at saving fuel and we want to spend less money on fuel. That is why we always choose a circuitous journey for any space mission. That is why here also we chose a circuitous journey rather than a direct journey, so that we can save less money on fuel. Specifically, when I'm talking about Aditya L1, I'll talk about why is it important. There are 5 Lagrange points, okay, between the Earth and the Sun. Here is the place where Aditya L1 is situated. Here is the moon, and here is the earth, and here is the sun. What is a Lagrange point? A Lagrange point is basically an area where the pull of two great heavenly bodies is so much that this place seems to be stable. Supposedly, Earth is trying to pull gravitationally an object towards itself from here. Similarly, the sun is trying to pull the object towards its side because of the gravity. But now, both these heavenly bodies are putting so much pressure that this seems to be stable. The hovering capacity of any object which is placed here increases because of the place it is situated between these two heavenly bodies. And L1 unfortunately is unstable. However, we have chosen this so that we can get continuous viewership of the sun. If continuous viewership of the sun is available without any eclipses, we will be able to understand the sun better. But course correction has to be done. Every few days, what will happen? Aditya L1 will drift away from this place because this is an unstable point. So it will use the fuel in order to go back to the place it was earlier standing. So remember all these kind of things. A Lagrange point is a point in space where the gravitational forces of two large bodies balance the centrifugal force experienced by any smaller object, allowing it to remain fixed in that area. For any two celestial bodies, there are generally five Lagrange points, 1 to 5. There are three unstable points here, L1, L2, and L3. L4 and L5, here is L4 and L5. These two are completely stable, but L1, L2, and L3 are unstable points. Okay, moving on. Halo orbit was chosen. Why? To continuously view the sun without any eclipses. Every geomagnetic storm flows from the sun towards the earth. It passes through L1. So we have to understand how we can keep our satellite safe. Also, it can remain in a fixed position with minimal fuel consumption. However, it has to do course correction in the middle. The L1 point is actually home to Solar and Heliospheric Observatory satellite, SOHO, which is an international collaboration project of NASA and the European Space Agency. Moving on. The payloads which are carried by Aditya L1 are many. Remote sensing payloads are there, such as WELC will go to study solar corona imaging. Then we have SOOT. SOOT is going to study UV imaging of solar photosphere and chromosphere. Solar Low Energy X-ray spectrometer SOLEX is going to study solar X flares. Aditya Solar and Particle Experiment is an in situ payload. It will conduct experiment. It will study the solar wind and energetic ions. Here it will also, here another one is PAPA. It is going to study the solar wind and energetic ions. Again, moving on, advanced triaxial high resolution digital magnetometers. It is going to study in situ magnetic field. Next is the Venus orbiter mission, which is also known as Shukrayan 1. It is going to be launched by ISRO in the year 2031. The objectives will be to study the geological structure, the surface, the atmosphere and solar wind interactions at Venus. Launch vehicle is going to be either GSLV Mark II or Mark III. Payloads that it is going to carry include synthetic aperture radar, ground penetrating radar and Venusian neutrals analyzer. Earlier, the launch date was 2024. But because we get an optimal launch window that minimizes the lift of fuel because we want to save money on fuel, it is very, far away. 8 years only we get this time. Every 8 years, we are going to find a place, find a time, find a window where we can do perfect lift off at minimum fuel consumption. That means 2031 is next. All right, moving on. Also, we have to know about the Bharatiya Space Station, the Indian Space Station. ISRO is working to set up Bharatiya Antariksh Station, our own space station. The station will be assembled in a phased manner. That means parts and modules will be sent, and by 2035, these will be assembled in space, and our own space station will be standing over there. The first module will be sent by 2028, and in the next 7 years, other also will be sent, others will be sent. That means by 2035 we will have our assembled place over there. This is likely to be an 8-ton module that is going to be launched by 2028, will be done by India's LVM-3 rocket. Moving on, let's talk about the ExpoSat mission, which was launched by PSLV C-58. It was set into the lower earth orbit. It is India's third space based observatory. First was Astrosat, space-based. I told you, right, that space-based solar observatory to study the sun, Aditya L1, which is also space-based and it is going to study the solar area. Astrosat was launched in 2015. It was a dedicated space satellite. Okay, it was to understand the different areas of space. So Astrosat is first, second is Aditya L1, and then we have Exposat mission. It is going to study X-ray, optical, and UV spectral bands, X-rays and electromagnetic radiation with higher energy and frequency, shorter wavelength than visible light will be studied. It passes actually through most objects, including the body, and produce images of internal structure. Okay, moving on, let's talk about the Gaganyaan mission. The Gaganyaan mission actually is the first human space flight program of ISRO in low Earth orbit. All right. Also, the launch vehicle is GSLV Mark III, which is also known as LVM-3. LVM-3 and GSLV Mark III are the same thing. Just don't get confused. All right. Payloads include crew module and service module. Crew module will be consisting of course, the crew members, which are 3 astronauts, and service module will consist of the area which can be used for servicing the crew module. Two unmanned missions are there, G1 and G2. G2 will carry Vyomamitra. Vyomamitra is a woman-looking humanoid robo. Woman-looking humanoid robo. Who is going to do what? She is going to help the astronauts in understanding the situation over there. One manned mission will carry 3 Indian astronauts to the lower Earth orbit for approximately 3 to 7 days. We have to bring them back safely as well. Lower Earth orbit includes 300 to 400 kilometers from the surface, from the above the mean sea level. Thereafter, India become the fourth nation in the world to launch a human spaceflight mission that is going to happen in 2025. Who are the two countries? Which are the two countries which are helping India in achieving it? Russia is helping us in getting training for the astronauts. So that is of course going to be very important. France is also cooperating with India for the Gaganyaan mission. The four important people we have to know about include Group Captain Prasant Balakrishnan Nair, Group Captain Ajit Krishnan, Group Captain Angad Pratap, and Wing Commander Subhanshu Shukla. These are the four men who are going to be aboard on the Gaganyaan mission. Remember that. INSAT 3DS is developed by ISRO, an Indian meteorological organization, because it is going to understand the weather related events. That is why it is important for us to know about IMD's creation as well. It is the continuation. It is continuation of the different generations of INSATs. Okay, it is funded entirely by the Ministry of Earth Sciences. So if it is asked, remember, it is funded entirely. Not a penny was taken from any other organization, because Ministry of Earth Sciences looks at the weather related events. That is why Ministry of Earth Sciences is spending. It was launched by using GSLV F14, which is also touted as the naughty boy. I have told you about this. It is known as the naughty boy of ISRO. Why naughty boy of ISRO? Because it seldom tends to not work well. That is why GSLV F14 has been dubbed informally as naughty boy. GSLV F14 is supposed to take NISAR as well. So it is going to perform well, we hope so. Moving on, it is a 3-stage launch vehicle. Its lift-off mass is 420 tons. The first stage and second stage is powered by a solid propellant. The third stage is cryogenic liquid. Primary object is to understand the Earth's surface and oceanic environment across multiple spectral channels, which enhances the data collection so that better weather related forecasts can be made. INSAT 3DS comprises of 4 payloads. Sometimes payload numbers and what do they do can also be asked. So let's talk about the numbers. It has an imager, a sounder, a data relay transponder, and a satellite aided search and rescue transponder. Let's talk about the NISAR mission, which is a joint venture of NASA and ISRO. It will be placed in the low Earth orbit. It will be a low Earth orbit observatory. GSLV Mark II launch vehicle will use it. It will map the entire globe in 12 days, properly producing enough content for us to do research. It will help to understand changes in Earth's ecosystem, ice mass, vegetation biomass, sea level rise, groundwater, and natural hazards such as earthquakes, tsunami, volcano, and landslides as well. It will consist of synthetic aperture radar that will operate the sweep-SAR technique. We'll talk about that as well. It is mounted on an integrated radar instrument structure. Also, thermal vacuum testing is a type of environmental testing which stimulates space conditions to evaluate the performance of spacecraft and other hardware. Synthetic aperture radar actually uses radar antenna motion to generate synthetic aperture comprising surpassing the size of the physical antenna. It works by transmitting pulses of microwave energy towards the Earth's surface. Here it could be written radio wave, but remember it does it in microwave energy. The energy reflected, which reflected back to the Earth to the radar, is then analyzed to create image of the surface. All weather operations, high resolution imaging, day and night operation, everything will be done it. Sweep SAR is NISAR's deployable antenna. It will operate in a unique mode called sweep SAR. So this is an antenna which is going to work with sweep SAR in this particular manner. When it transmits microwaves, the radar signal's feed is stationary, produces a narrow beam of microwave energy, and but when it receives the returning signal, the radar feeds sweeps its beam across the antenna's reflector. Okay, thereafter sweeps are employs a one-dimensional phased array feed of evenly spaced individually controllable radar antennas which is arranged in a row. Advantages: we get high resolution image, we have wide area coverage, and a swathe is the ground area that is imaged in a single pass of sensor. So that is also going to be time saving. Indigenous climate forecasting system has been managed. The IITM-ESM, Indian Institute of Tropical Meteorology Earth System Model, it has been indigenously developed without any external assistance for a center for climate developed at the Center for Climate Change Research. Remember that. The IITM ESM is an Earth system model which has been developed under the Ministry of Earth Sciences. This India's first ESM, and it was also used in the sixth assessment report which was employed by the Intergovernmental Panel on Climate Change or IPCC. Moving on, let's talk about now other important space related events. Noisy gravitational wave background has been found out by scientists that these kind of background noises exist, and these waves create a cosmic background hum. It's like a noise in the universe. Albert Einstein did predict it in his general theory of relativity that entire universe is a space time fabric, and when there is any event in this fabric, such as the emergence and convergence of two black holes or something like that, that creates noisy background waves. And this has been found out perfectly now. It's a ripple in the fabric. Whenever any event happens in this particular big fabric of space and time, then any event, if it happens, it creates a ripple, and that is felt all over the universe. So we are able to catch it in the form of noisy gravitational wave background. Okay, moving on. Space and time actually don't exist as independent entities. These are together. That means the entire space is divided into time, and the time is measured in the form of distance. Combining the three dimension, which is height, width, and depth of space, and one dimension of time into a single four-dimensional continuum is known as space-time. The first time ever we understood the general theory of relativity coming to life was through the Laser Interferometer Gravitational Wave Observatory LIGO of the USA, which actually recorded that two colliding black holes occurred nearly 1.3 billion light years away, which means it was 1.3 billion years ago. And since then, it was able to reach recently in USA, as in on the Earth. Moving on to the next one, Artemis Accords. India has become the 27th signatory of the Artemis Accords. It is a US led initiative, and other founding members also include, because founders can also be asked. So remember, Australia, Canada, Italy, Japan, Luxembourg, UAE, and UK have been the founding members. India has also signed this particular accord, and now we are the 27th signatory. What are Artemis Accords? These govern civil explorations, not military, and use of outer space and celestial bodies for peaceful purposes. So, if it is ever asked that it also governs military exploration, no, only civil exploration. It is also non binding. That means it is not completely going to legally bind any country to do one thing or not do anything. Okay, so it is just like an outer space treaty, but we are wanting something more than that, because we are seeing that the space is now continuously and exaggeratingly being used for military purposes as well. The closely linked to the Artemis program it is, which aims to return astronauts to the lunar surface. Criticisms are there that the legal status is uncertain because there is no provision to regulate something civil, so civil such as mining for the benefit of one country. And let's talk about Astrosat. For the first time, it measured X-ray polarization from Cygnus X1 black hole. Astrosat is India's first indigenously built, dedicated, multi-wavelength, space-based telescope observatory to study distant celestial objects in X-ray. It will use optical areas and UV spectral bands as well. It was launched in 2015 by ISRO into near Earth equatorial orbit. So remember, it's not low Earth orbit, it is near Earth equatorial orbit with a minimum useful life of 5 years. The objective was to understand the high energy process in binary star system, stars which exist in binaries, estimate magnetic field of neutron stars, study star birth regions and high energy processes in stars lying beyond our galaxy. So it was not only limited to our galaxy. A question could be formulated that it is limited to our own galaxy only. No, it can move beyond our galaxies as well. Let's talk about Cygnus X1. It is one of the first confirmed black hole system in our galaxy. Cygnus 1 is in Milky Way only. It is 20 times heavier than the Sun and has a companion, which is a heavy supergiant star in a binary system. That means there are two brothers. Moving on, let's talk about fast radio bursts and neutron stars. These are powerful yet fleeting electromagnetic radiation emission, which are seen in radio wave frequency. Keywords here are radio wave frequency and electromagnetic radiation. Exact source, we do not know it as of yet. A question could be asked that these are confirmed to come from emerging black holes or converging black holes, destruction of stars. We do not know what fast radio bursts, from where it does come. The leading hypothesis is that the neutron stars, specifically magnetars, they could produce fast radio bursts. These are abrupt, powerful flashes which is picked up by radio telescopes only. So here is a usage of word, extreme word, only. So remember, only by radio telescopes we can get it. These are at least 15 till now have been found to repeat. This has added the challenge of explaining what might be behind them, but here is one of the possibilities. Let us see. Supposedly, any magnetar has thrown a big flare of ejections, and here new debris has come into being, and old debris has also met it. Then a magnetic field change has been seen. High frequency signals were given out, shock slows, and then lower frequency signals were developed after this. This is one of the theories. We are not known what is it actually. A magnetar releases an eruption of electrons and highly charged particles, an ejection. The flare then collides with the remnants of previous eruption, the debris. It generates a huge magnetic field, and then there is the high frequency signal which is converted into low frequencies. These are just milliseconds but generate as much energy as the sun does in 10 years. This is such a takeaway for your prelims examination. Now it is estimated that 2000 FRBs have occurred daily on a daily basis, but only about 100 have been detected to date. So remember how it is formed. A magnetar basically throws a flare of electrons, then it goes and strikes into the old debris. The old debris was done earlier, a basic ejection of old electrons. Then high frequency waves because of that occur, and thereafter they are low frequency waves. This kind of theory is right now standing, and we do not actually know is it really true or not. We are just speculating. Deep space optical communication experiment is being done. Okay, and here it is NASA's Psyche spacecraft which is successfully fired a laser signal on the Earth. Psyche spacecraft belongs to NASA. Space communications data rate problem will be solved by this. Spacecraft encode data on various bands of electromagnetic frequencies, like radio waves mostly. Higher bandwidths range of frequencies carry more data per second. Higher bandwidths will shorter wavelengths, scattering problem, all will be solved. Moving on. NASA's Deep Space Optical Communication Experiments uses near infrared laser signals for communication with spacecraft. This is a takeaway for prelims. Limitations are there on propagation of higher bandwidth. It is going to overcome by extreme precise pointing. Let's talk about most reflective planet. European Space Agency's exoplanet probing CHEOPS. Remember CHEOPS? CHEOPS is our friend. CHEOPS Space Telescope has discovered the most reflective planet, exoplanet, by the name of LTT 9779b. It reflects 80% of the light from its host star. It does get only 20%. After that, how much it uses, we are not known for that. It's surviving in a region called Neptune Desert. It has metal clouds with raindrops of titanium. Titanium flows there. The planet's metallic clouds actually act like a mirror because the clouds are reflective in nature. That is why 80% of the light is reflected. Moving on, Neptune Desert is defined as a region which is close to a star where no Neptune sized exoplanets are found. So remember this, because this region receives strong irradiation from the star, and so the planets cannot retain their gaseous atmosphere. It is all flown out. They evaporate just like rocky core. Exoplanet types include terrestrial, Neptune like, super Earth, and gas giant. We have a very close exoplanet, and it is by the name of Proxima Centauri b. It is orbiting a red dwarf star just about 4.25 light years away, very close. Exoplanets can be very big, like Jupiter, or small as Earth. This is Proxima b. This is just the artistic representation. It is nothing like the Earth. Moving on. MOXIE has successfully generated oxygen in Mars. NASA's MOXIE, which is Mars Oxygen In Situ Resource Utilization Experimentation, has successfully converted Martian carbon dioxide into oxygen. That means we can soon live there. Yay! We all are Martians now. 98% purity or better suitability is there for both fuel and breathing purposes. MOXIE is aboard at the NASA on the NASA's Perseverance rover. Remember, where is MOXIE? Because this could be asked. NASA's Mars 2020 mission, and it had landed on Mars in 2021. It is also exploring the Jezero crater on Mars. Remember, because crater related questions will be asked for sure. Moon is full with craters. It's filled with craters. That is why craters on other planets can also be asked. It is doing so in search of signs of an ancient life, not current but ancient. If any life did exist, what happened to it? Note 3 satellite was launched by Iran. It is designed primarily for imaging purposes, but it has potential spying capabilities. It is put at an altitude of 450 kilometers. The launch vehicle was a three-stage Qasid. That means Qasid means messenger. Okay, it was developed by Iran only, and this was developed by Iran's space aerospace arm by the name of Iran's paramilitary Revolutionary Guard Corps, and the predecessors of new three satellites were also there. Odysseus has landed on the moon. Nova C lander module, which is part of the Odysseus, it landed on the moon's south pole region. Again, we have to understand it from the perspective of your examination, specifically after Chandrayaan 3. This is the first moon landing by any private company, and this is all a part of the Artemis program. Third moon landing was within a year has been done after Chandrayaan 3, and Japan's SLIM means Smart Lander for investigating the moon. Odysseus is a spacecraft for Intuitive Machines company, which uses a Falcon 9 rocket for SpaceX. Okay, then we talk about Osiris Rex, which is going to study asteroids, of course. Let's talk about asteroid Apophis, which could be a planet killer. It is named after the god of chaos, which is a near Earth object about just 1100 feet across. That is 340 meters across. It is made up of silicate material and nickel iron. It is different from carbon rich C type Bennu. Okay, so how it is different from Bennu? This could be asked in your examination. It originated in the main asteroid belt between Mars and Jupiter. We know that between Mars and Jupiter, a belt is there of asteroids, and here only asteroid Apophis is originating or originated. This was discovered in 2004 and it is one of the most hazardous asteroids that could impact the Earth, and but it is being said that it is going to safely pass very close to the Earth on April 13, 2029. So we are safe as of yet. It is the closest approach to Earth by an asteroid of this size that scientists have known about in advance. It is expected to change the asteroid's orbit and the length of its 30.6 hour day. Officially, the taken off it has been taken off from NASA's potentially hazardous asteroid list. It has been taken away. Earlier, it was potentially hazardous, but recently it was taken away. Other asteroid missions include Galileo mission, which is the first spacecraft to fly past asteroid Gaspara in 1991 and IDA in 1993. Then we had the NEAR mission, which was the first spacecraft to successfully orbit and land Eros, which was an asteroid near Earth. Mission Lucy for exploring Jupiter's Trojan asteroid. Match the following could be asked. Then we have Dawn mission, which aimed to study 2 out of 3 protoplanets in the asteroid belt between Mars and Jupiter, that is Vesta and Ceres. These kind of questions are favorite. UPSC can ask you from here. Dawn is the first to visit the dwarf planet Ceres, the first to orbit a body in the region between Mars and Jupiter, something that you have to remember. And the only mission even to orbit 2 extraterrestrial targets. Ada mission is also there. Hayabusa of Japan is there. It brought samples from asteroid Itokawa. And Hayabusa 2 is going to target Ryugu, very importantly. Moving on, let's talk about the last news, which is very important. Russian cosmonauts record in space. Oleg Kononenko, who is a Russian cosmonaut, set record for spending the maximum time in space. Remember his name. He was sent to the ISS via Soyuz MS-24 mission, which was launched from Baikonur facility, which is situated here in Kazakhstan. Baikonur Cosmodrome is world's largest space launch facility located in Kazakh, but it is managed by Russia. And Soyuz Russian space vehicle was used for transporting and is being used for transporting crew to the International Space Station. It also acts as an emergency escape vehicle permanently docked at the ISS. The Soyuz Russian space vehicle is being talked about here. Alright, so I hope you understood what kind of questions can be asked, and please do subscribe to my channel. Make sure that you are sharing this with your friends so that I can get more support on YouTube. Thank you so much, everyone. Keep yourself updated.